On July 1st, 1940, the Tacoma Narrows Bridge in Washington was opened after over a year of construction. Unfortunately, after the bridge opened, it took only mere months for it to collapse. The video of the moments before collapse is one of the wildest videos I've ever watched. The video was taken on November 7th, 1940. The bridge lasted for not even 5 months after construction. So what took it out? I think anybody with eyes can guess that it was the wind, right? The thing that shocked me most about this incident is that the wind was blowing 40 miles per hour. That's 64 kilometers per hour for all of you people who use a measuring system that actually makes sense. As someone who lives in the Midwest, 40 mile per hour wind gusts are fairly common enough that you would definitely build a bridge to withstand that. For the record, I don't think they intentionally built a bridge that falls into the water because of a mild wind gust, so what happened? Understanding why the engineering failed, we need to go back and examine what the engineers had to say. The first design proposed to be built was a conventional suspension bridge. The bridge was going to cost $11 million, or $220 million in today's money. The plans included a set of 25-foot deep trusses under the roadway to stiffen the bridge's design. I bet you'll never guess why this design didn't make the cut. Finances. Yep, it always boils down to money. Personally, I sleep easy knowing that all of our infrastructure is built as cheaply as possible. With just high enough standards, we probably won't die. Another proposal for the design came in that cost only $8 million. This design was suggested by the same guy who designed the Golden Gate Bridge. This cheaper design included a more sleek and futuristic look. Instead of 25-foot deep trusses, there will be 8-foot deep plate gliders. Plate gliders are a lot like trusses, but unlike trusses, plate gliders are solid and don't allow air to flow through them, causing more wind load. It was also said that the main cables would absorb half of the static wind load on the bridge. I'm sure that all sounded like a good idea on paper. Sounds convincing to me. I'm not an engineer. Ultimately, the biggest problem with this design was the length and expected traffic volume. This bridge was expected to have a relatively small amount of traffic. Because of this, it was built with only 2 lanes, making it only 39 feet wide. At the time, it would be the 3rd longest bridge in the world. The impressive length, paired with the narrow road deck and downsized support, made the bridge especially bendy. As if it couldn't get worse, while researching this bridge, I came across many big words written by people much smarter than I am. This bridge has been used extensively for education material and what to definitely not ever do again. I also found this equation just in case any of you want to follow along while I break it down. I channeled my inner physicist and decoded all the big words for you guys. The bridge failed because it was bendy. But no, really, it was bendy enough and long enough that the road deck would literally develop waves, like water. This caused a chain reaction where the wind would cause movement, and before the road could stop moving, the wind would catch it again, causing even more movement, and so on and so forth until there was so much movement the bridge failed. Several attempts were made to stabilize the bridge after it opened, but obviously none of them worked. Cables were attached and anchored to 50-ton concrete blocks on the shore to help stop movement, but the cables snapped shortly after attaching them. I can only imagine what it must have been like to be part of the crew tasked with building this bridge. Building bridges is dangerous business under normal circumstances. But just imagine how scary it must have been when the untested project you're building starts swaying in the breeze. I bet they vowed to never set foot on the bridge again after they finished construction. Even the project engineer had this to say about the day of the collapse. "It was my bridge. I was in my office about a mile away when word came that the bridge was in trouble. At about 10 o'clock, Mr. Walter Miles called from his office to come and look at the bridge, that it was about to go. The center span was swaying wildly, it being possible first to see the entire bottom side as it swung into a semi-vertical position, and then the entire roadway. It seems to me that since they were looking for ways to stabilize the bridge, they obviously recognized the swaying as an issue. I know hindsight is 20/20, but I can't believe they were still letting traffic cross the bridge, even as the wind picked up. To my knowledge, nobody lost their lives because of the collapse. There was at least one abandoned car on the bridge as it collapsed. Here is an eyewitness account from a 25-year-old college student who decided to walk the bridge the morning of the incident. After walking to the tower on the other side and back, I decided to cross again. It was swaying quite a bit. About the time I got to the center, the wind seemed to start blowing harder all of a sudden. I was thrown flat. A car came up about that time. The driver got out, walking and crawling on the other side. We didn't have time for any conversation. Time after time, I was thrown completely over the railing. When I tried to get up, I was knocked flat again. Chunks of concrete were breaking up and rolling around. The knees were torn out of my pants, and my knees were cut and torn. I don't know how long it took to get back. It seemed like a lifetime. During the worst parts, the bridge turned so far that I could see the Coast Guard boat in the water beneath. When I got back, I remembered the bridgeman had said something about a dime each way. I mentioned it to him. He said, "Skip it." The people had wanted a bridge over the Tacoma Narrows Strait for many years. The long-awaited bridge lasted only 4 months and was not rebuilt for another 10 years because of World War II. Evidently, the second bridge was of higher quality because it is still standing today. It seems we've learned our lesson about cutting corners with bridge construction.